By the year 2500, Earth could become a completely alien planet if humans continue to destroy the environment. Numerous scientific studies have demonstrated the long-term impacts of climate change. The projected increase in greenhouse gases, temperatures, and sea levels by the year 2100. For example, the Paris Agreement requires keeping the global temperature rise below 2.0 degrees Celsius by the end of this century, compared to the pre-industrial era. Every few years since 1990, environmental scientists have conducted activity assessments. Here are the two English translation options, depending on context. The IPCC reports compile and analyze current research, thereby identifying our position in the fight against climate change. To achieve the set goals, what specific actions do we need to take before 2100? And what happens if we don't achieve the goal? The recent United Nations report on the assessment of nationally determined contributions, NDCs, issued a warning that humans could face dangerous warming levels of up to 2.7 degrees Celsius by 2100. This means there will be massive wildfires, violent storms, prolonged droughts, severe floods, and unprecedented heat waves in recorded history, and alter the underwater ecosystem. If children born now are only 70 years old by the year 2100, what kind of world will their descendants live in? By 2100, will Earth stop warming? Otherwise, how will this affect the lives of people today and future generations? In a recently published article in the journal Global Transbiology, scientists have begun to find the answer to this question. Scientists have run a global climate prediction model based on the representative greenhouse gas concentration scenario (RCP). This forecast is time-dependent, reflecting changes in greenhouse gas (GHG) concentrations in the atmosphere. The forecasts were developed based on the RCP 6.0 emissions reduction scenario model. The moderate RCP 4.5 and high RCP 2.6 scenarios align with the goals of the Paris Agreement. Below 2 degrees Celsius until the year 2500. They also developed distribution models for vegetation, temperature, and growth conditions of current key crops. To understand the environmental challenges that current children and future generations may face from the 22nd century onward, researchers found that under the RCP 4.5 and 6.0 scenarios, the global average temperature will continue to rise even after 2100. According to these scenarios, vegetation and the most fertile farmland will gradually shift toward the two poles. And the suitable area for growing certain crops has also shrunk. Long-standing biodiverse ecosystems like the Amazon River Basin are at risk of becoming barren. Moreover, they found that temperatures in densely populated tropical regions could reach life-threatening levels. Areas like these could become uninhabitable, even under the most extreme mitigation scenarios. Scientists have discovered that sea levels continue to rise steadily, primarily due to the warming of ocean waters causing thermal expansion and stronger disruptions in ocean currents. Although these results are based on a specific climate model, they still fall within the range of predictions from other models, and contribute to clarifying the extent of potential climate change over long-term cycles. To truly envision a world with extremely low or high temperatures, we need to compare it to our familiar temperature experiences so far. They utilized multidisciplinary expertise and predictive capabilities to create a set of 9 paintings outlining key timelines: the years 1000, 1500, 2020, and 2500. Among the 3 main landscape regions are the Amazon, the American Midwest, and the Indian subcontinent. The Amazon rainforest. The image depicts a traditional indigenous village before 1500, the time when they first encountered the modern world. In the photo, a trail leads to the riverbank, and cultivated fields lie nestled within the lush tropical forest. The photo in the center shows the current landscape. The image below depicts the scene in the year 2500, revealing a barren land with significantly lowered water levels due to severe vegetation loss, with sparse or deteriorating infrastructure and a landscape nearly devoid of human activity. The Midwest region of the United States. The first painting depicts the pre-colonial era, featuring images of indigenous cities and communities with their houses, alongside a diverse agricultural system primarily based on corn. Second, in the same area today, there are cereal monocultures with vast fields and modern harvesting machinery. However, the final image reflects the adaptation of agriculture to the hot, humid subtropical climate through an agroforestry model built upon oilgrass and drought-resistant cacti. The crops are comprehensively cared for by AI, minimizing human intervention to the greatest extent. The Indian subcontinent. The photo captures the bustling scene of an agricultural village, where locals are busily engaged in farm work, livestock tending, and daily routines. Second, the current landscape reflects a harmonious blend of the traditional beauty of mountains and rivers with modern infrastructure systems, emerging in many regions across the global south. The final photo depicts a vision of future technologies capable of adapting to temperature changes. The future is like a world beyond Earth. From 1500 to the present, humanity has gone through the period of colonization and the Industrial Revolution. The formation of modern states and institutions, along with the rampant burning of fossil fuels, has led to increasingly rising global temperatures. If global warming cannot be stopped, the Earth will change completely in the next 500 years and beyond. By setting challenges to the ability to maintain the essential elements that ensure our survival, the Earth in high-level projections is an unfamiliar place to humans. The urgent choice we must face is cutting emissions, while still having to continuously adapt to the warming of the Earth, an unavoidable reality. Or begin to imagine that life on Earth in the future will be completely different from anything we've ever known. Mystery_Core compiles and reports from the source coahawk.tv.